Welcome back to this next chapter on classification and differentiation. This is the day for the mathematical background and the mathematical thinking behind neural networks developed in the 21st century. So we want to go to these. Let's make it a little bigger. So what is classification? In the classical way, we follow the same scheme like like the last chapter, but not on prediction, but on classification. We don't have to explain the difference between function and equations again. So we go to classification and then how the aliens are doing it, or AI is doing classification. I would say this is about differentiation. So go for classification. So if you have predictions, you produce individuals with specific machines. This is what is discussed. So classification sees an individual and asks for the machine it was made with. So therefore, prediction is going forward in time and classification is going backward in time. And I think that's it. So therefore with prediction you have the problems with error and that things go a little diverse. With classification you're looking for the very origin, like we tried to do with all theories, what with Logier, with the primitive hut and so on. We try to find the origin of all buildings. Yeah? Therefore, predictions are continuous and not exact, and classifications are discrete and exact. So, therefore, we had this with the ideal and then the reality. Predictions goes from the ideal to reality, and now classifications goes from reality to the ideal. That's it, I would say, to make it. So this, for example, is a classifier in a classical way implemented with our calculus. So it's a selector. It says if A is greater than O, this is forward. If it is less than O, then it's backward. And if it's equals O, then say stop. Which means if I say selector with 3, it's forward. If it's with -3, it's backward. And you can do here, in this you see, you can have any kind of value, it's still backward. So it's discrete as a result. So you have an ideal from out reality classification. So that's a classical way. And now we directly can say, again, aliens are not in time. They don't care about the ideal and the real, or they have no access to it. They do different. So it's the same thing like we had with the prediction, but here we simply say 3 is forward, 1 is forward, -3 is backward, -2 is backward, O is stop. These are our examples. And now again a superfunction. Classify instead of predict examples. Then again we simply train a network, and it's now packed as a function, and we simply say ask now select classifier of 3.4 And he says it's forward. He knows. And it's again the same story like prediction. So aliens sitting at the edge of the world, at the end of the time, they take pictures of the world from different perspectives, two perspectives, and they say it's the same, and by that they just can make classification. So if you look how this is done, and then a work, and this you ask here for the probabilities, and then he says, if I'm with -1, what are the probabilities? He says I'm 45% a B, 26% is an F, and 27% is 0. So maybe this is getting more drastic. If I go here, yeah, you see it's very sure that it's a B. So if you get more examples, all this gets more crisp and safe. So, yeah, therefore, again, I would say it's not, there's no ontology, there is no understanding. It's simply say it's the same. People, so if it is, for example, of this degree, people say it's hot, or it's fast, or it's forward, or whatever. So then you simply say, if they say, I don't care, just keep it in mind, put speed and the name the same, and then you know how to talk about it. Make your reason about this. So it's just a difference, and that's it. You don't need an ontology, which, for example, is very constituent for, surprisingly, when this came up, this kind of technology, we start to talk about ontologies, object-oriented ontologies. Just the moment when it's definitely with the leading technique and the most pushing technique available, the whole internet is working like that, that you don't talk about ontologies anymore, people start to talk about ontologies. I don't really understand it. With building information model, it's the same. So you don't need it as an alien to have ontologies. So it's about differences. So if you want to learn from other buildings, one building has to be the same with the others, and then you simply say it's the same, and you have different perspectives to that. Like the perspective drawings in Renaissance, you simply put it at a different angle, and you simply say it's the same, and it's there. So you have one eye, the other eye, same, and say, then reason about what's going on there, and then you're able to read this alienated drawing about something real. So that's, I think, it is. So it's not about classification what we are doing here with the aliens. It's just about making differences. And this is very in line, and this is most interesting with Renaissance Baroque thinking. And look at Descartes' method, the geometrical calculus, the differential calculus of Descartes. It's exactly where we are in another abstraction. So, next thing will be the principal challenge we have if we are on a gravitational body. This classical thinking, which is combinatoric explosion, and I will show you that aliens don't have this problem. Thanks for watching. See you in the next chapter.